Hello and welcome. In this video, I just walk you through the concept of a callback with respect to system Verilog version of a UVM. Already, I have covered this concept in the previous video, but that video has some voice problem. Let's try to understand that same concept here in this video. Okay. So before proceeding to this concept, let me explain you the design which we are taking to understand this concept. So this is what a simple combinational ladder. Already I have uploaded a video on the verification of a combinational ladder using system Verilog version of UVM. I request you to first go through that video and then proceed for this video. Then you will find this concept easy to understand. I will put a link of this video in the description so that you can go through the combinational ladder video first. Okay, so this is what a simple RTL, which consists of two inputs A and B and one output, and the output is just a addition of two inputs A and B. And this is what a simple interface for this RTL. We are defining all the inputs and outputs as a logic. Right now we are considering a very simple interface. Let me explain you the concept of a callback. So if you see the literature, you will find that there are many definitions of callback. And the simplest one is the callback is the mechanism by which we can get the additional behavior from the transactors by customizing the empty methods. So transactor means the classes those are dealing with the transaction. Okay, so let me explain you a very simple example. As you know, the responsibility of a monitor is to capture the information from the user with the help of virtual interface. In addition to this responsibility, if you want that our monitor should print some info messages before capturing the information and after printing that information, if you want it should print some messages, we can do that with the help of this callback without really modifying the monitor class. Just we can customize the empty methods, those we are defining in the callback class. So it means that without really modifying the source code, we can get the additional behavior from the transactors by just customizing this empty methods. Okay, let me explain you how we are doing that in this example. All the things are same. I'm not going to explain the things as already I have explained in that verification of a combinational ladder video. Please go through that video once so that you will understand the entire concepts in a clear way. So this is what the transaction class, the responsibility of transaction class is to keep the inputs and outputs of our DUT. Sequence class is there. Okay. Sequencer class. Now here let me explain you the callback class. So this is what a simple callback class monitor callback, our own name, which is extending from UVM callback. And as it is a component, as it is an object class in the UVM based class hierarchy, we have to register with tick UVM object details factory registration method and its default constructor expecting 1. Now here I'm defining two empty methods called presend and postsend, and I'm making them as a virtual so that in future if I want to override these methods I can override. So this presend and postsend, two empty methods I'm defining. End class monitor callback. Now I'm extending a class called monitor callback 1, which is extend from monitor callback. So this monitor mon underscore callback is a parent for this mon underscore callback 1. As it is also an object class, we have to register with tick UVM object details factory registration method and its default constructor expecting one. Now here I am customizing those pre and post same methods. Okay, so as you can see, virtual task pre-send. Here I am writing a very simple info. Get type name which will print the current class name. Here I am writing the pre-send defined inside of monitor callback and the verbosity is UVM. Similarly for post send, I'm defining a message post send defined inside a monitor callback. End class monitor call. We are not doing anything inside the driver class, so it will be same only. Let me show you the monitor class, okay, in which we want this additional behavior. Now, monitor class, which is extended from UVM monitor. As it is not a parameterized class, we have to define the instance of a transaction class. Then the interface, we are defining virtual because the interface and static component, and this monitor class is dynamic in nature. Okay? And the name instance for this is VIF. As you know, monitor has the analysis port. We are defining this using UVM analysis port, parameterized with the type of a transaction and our own name AP. Or sometimes it is also referred as a broadcast port. Okay, so it will broadcast this data to multiple components. For example, you can broadcast this captured data from the DUT through this analysis port to multiple components like scoreboard and coverage. Okay, as it is a component class in the UVM based class hierarchy, we have to register with tick UVM component details factorization method. And here, in addition to this factorization method, we have to use this tick UVM register CB. This is what the callback, if you want to register our monitor class, okay, this is a monitor, okay. If you want to register our class with callback, we have to use this callback registration method. In the parenthesis, we have to provide the monitor class name and the callback class name, in which we define two empty methods. Okay. Now, as it is a component class in the UVM based class hierarchy, its default constructor expecting two arguments. In the build phase, we are allocating a memory using factories create method for this transaction object, and we are getting the virtual interface using get method. In the run phase, which is a main phase for a monitor, we are defining a forever beginning block. In this, we are defining the callback hooks. So tick UVM do callback within parentheses the monitor class in which we want the additional behavior, comma the callback class in which we define two entry methods pre and post, comma we are defining this pre-save. Okay. So now it has three arguments, right? Then we are capturing the information from the DUT with the help of this virtual interface. So we are putting that inside a transaction object. So trans.a.b.y is equal to virtual interface.a.b. Again, we are using blocking assignment to capture the information from the DUT through this virtual interface. So what we want before capturing this information from the DUT, we want it should print the message which we define inside of that pre-send method, inside that pre-send method. Okay, and after printing, after using this print statement, okay, and then after putting that transaction, collecting that transaction inside this analysis code, we want to print the info which is there inside a post send method. So okay, so before capturing the information from the DUT, we are defining this tick UVM do callback, callback hooks, and after capturing the information from the DUT, we are defining this tick UVM do callback hooks. Okay, and this post send will print the message which we define inside a post send. So this Callback hooks actually linking our monitor. It will link our monitor with the callback class. So in the component in which we want the additional behavior, we can just make use of this w.r.p.t to callback hooks. We are not really modifying the code, just we are linking our monitor with the callback class here inside a monitor class. Then let me show you all other things are same. The agent in which we are defining the driver, sequencer, and monitor. In the build phase we are creating them. In the connect phase we are making the connection of the driver which has a port with the export of the sequencer. Okay, let me show you the top test class in which we have to use one add method. So inside a test class where we are defining the sequence, we are also defining the instances of a monitor and the extended callback class instance. So monitor underscore mon underscore callback one. The instance for this is cv. As it is a component class in the UVM based class hierarchy, we have to register with tick UVM component at inspect registration method and its default constructor expecting to R. Now in the build phase, we are allocating a memory for this monitor class instance and this callback instance using factories create method. And here we are using this add method in order to add our monitor inside a callback. Okay, so the syntax for that is UVM callback hash within parenthesis monitor class, in which we define the callback hooks to link our monitor with a callback, comma monitor underscore mon underscore callback in which we defined two NT methods, colon meaning the scores resolution operator, add method within parenthesis the instance of a monitor and the instance of a callback, extended callback, right? CV. And in the run phase, just we are creating the instance for the sequence using factories create method. And then we are raising the objection and dropping the objection. In between that, we are starting the sequence onto the sequencer which is there in the agent of the environment using the start method. And in the top, just we are defining the virtual interface, then our instantiating our design using name base, or you can use order base also. In the initial begin block, we are setting the virtual interface using set method, and then just we are calling a run test method and providing the argument as a test one. Okay, in which we define in which we are raising the objection, dropping the objection, and we are creating the instance of a monitor class and the extended callback class. And we are using the add method in there also to add our monitor class with the callback class. Okay. If you run this code, you will find the simulation result something like this. So if you analyze this result, you'll find this info is from the monitor class. Let me show you that monitor class here so that it will be easy to understand. So if you see this monitor class, okay, here first we are in the run phase. First we are calling this. We are using here the callback hooks and defining the presend. So that presend will be there here, as you can see. Okay, presend define inside a monitor callback one. Okay, so already we defined this callback. Okay, callback one. Here we define that presend, and here we are defining a message using info. Presend defined inside a monitor callback. So before capturing the information from the DUT, we are printing this message. And after capturing the information, we want this message should, monitor should print post and define inside a monitor callback. And if you analyze the monitor class, you will find here After capturing this information and after printing that, we are, you know, calling that post sale method. Okay, so after this print method, okay, printing the transaction which we captured from the DUT, you'll find a message, the post same defined inside a monitor callback. So this is what, the additional behavior we can get with the help of UVM callbacks. So right now we are here in the monitor not doing anything. We are not really modifying the codes. Just we are defining, the callback hooks here. So this callback hooks will link our, class, which is a monitor here, with the callback class. And with the help of this, callbacks, we can get the additional behavior in transactors. Okay. So with this, I hope you have understood the concept of a callback. Okay. And if you see the literature, you will find some use cases of callback. So the first, application of a callback we can use to inject the errors. Then we can use if you want to delay our transaction. Then if you want to skip some transactions, we can use this, callbacks to get that those, additional behavior in the transactor classes. Okay, so I hope now you understood the, need of callback with this practical example, the use of callback, what is callback, applications of callback, and also I hope you enjoyed this video. So thanks for watching this video. Thank you.